therefore minimizing the dwell time spent due to congestion in the course node. Now we shall look at the integration of the course node component, the continuous component, and the existing fine node model of building Exodus into an integrated approach called the hybrid spatial discretization. This novel approach involves the mixing of macroscopic and microscopic modeling methodologies, which in itself presents several challenges. Since we have 3 spatial representation types, this gives us a total of 6 interface transition regions. For instance, the agents will be transiting from course node to fine node to continuous, and course node to continuous, and vice versa. Building Exodus incorporates additional behavioral and movement mechanisms to facilitate transition across the interfaces. We shall look at one example of such transition, for instance the course node to the continuous. This transition represents the 2 extremes on the scale of granularity. So the course node component is connected to the continuous component using arcs, and the endpoints of those arcs are called waypoints. Now these waypoints are used to guide the initial position of the agents as they enter the continuous space. And the agent avoidance mechanism in the continuous space is triggered, which causes the agents to spread. Thereby the agents make a more realistic use of the available space. Now we shall look at the application of the HSD to a demonstration case. So as we can see here, we have a multiple compartment geometry with different sections of the geometry modeled using different spatial types. And the experimental setup was as follows. So there were a total of 300 agents with an average density of 2 persons per meter square in each compartment. There were no flow rate impositions on the exits, and the exits were set to free flow. The maximum travel speed of the agents was set to a fast walk of 1.5 meters per second with a response time 0 seconds. And the width of all internal and external exits was set to 1 meter. In order to compare the similarities and differences between each of those approaches, the same demonstration case was repeated using an all fine, all continuous, all coarse, and a hybrid configuration. And in the hybrid configuration, 40% of the space was represented as continuous, 30% as coarse, and 30% as fine. We shall look at each of those in detail. So firstly we have the all fine, which is made up of a 2-dimensional mesh of nodes. Next we have the continuous approach, in which the agents exhibit additional behaviors and attributes. And next we have the all coarse approach. So as we can see here, the location of the agents is now represented, so all we know is how many agents are present in a particular region at any point in time. And next we have the hybrid approach, and this particular configuration includes all the interface transitions, so all the total of 6 interface transitions. Now we have some results. As we can see here, all the curves pertaining to the different approaches are similar. However, the all course consistently underestimates the evacuation times, And the all continuous and the all fine approaches show similar histories. And the hybrid approach, which is the orange line here, lies in between the two extremes. So for instance, it lies in between the all course curve and the all continuous curve. So as you can see here, the hybrid approach demonstrates results of similar accuracies to that of the all continuous and the all fine approach. So lastly, some conclusions. So we've seen a new plugin architecture in Building Exodus which allows new modules to be included using a component-oriented approach. We've described a new navigational system based on a navigational graph used in the continuous and the course components in Building Exodus. We've seen a novel approach, HSD, which is used to represent spatial discretizations in circulation and evacuation models. And also this approach has shown to produce results of similar accuracy to the all fine and the all continuous approaches. And also this approach provides the flexibility in defining a mix of approaches, so we're not limited to using a single spatial representation type for modeling enclosures. Some future work. So more work has to be done to investigate the impact of using different combinations of these approaches on the accuracy of predictions and performance. Also, the numerical efficiency of the plugin components has to be optimized, and the HSD approach can be extended so that it works efficiently within the parallel computing environment currently offered by Building Exodus.